Hi there and welcome to Workshop 4. So in this workshop we're looking at two things really. The main one thing we're looking at is R Markdown, which is basically a way that we can combine blocks of R code that do analyses or manipulate data in some way or produce plots. That's the R bit of R Markdown. And Markdown, which is basically a markup language, a very simple one for creating basically formatted text from plain text. So that's the first thing we'll look at, and then we'll look at how we can evaluate the distribution of numeric variables like we did in Workshop 3, but where we're comparing across groups. So this is what it looks like. It's an R Markdown document. It's got the .rmd extension, okay, which stands for R Markdown file. And you'll notice that when you load it up, it obviously looks a little bit different. You have this little block at the top, which we'll talk about later on. This is called metadata at the top. It basically where you provide information about the document to kind of help it out, do its job. And then we've got a bunch of text here. Okay, so we've got introduction with 2 hashes before it. This is a level 2 heading. Okay, the 2 hashes indicate a level 2 heading. And so when we produce the final document, this will be a heading. And then we've got some writing here, all about Markdown, and there's various embellishments along the way. So for example, the like this here is surrounded by 2 asterisks, which will make that bold, whereas the single, the italics word here is surrounded by a single asterisk, and so that will become italics. And you can do a bunch of other things, obviously. There's bullet points in the usual way. Okay, just use a little a minus and then a space and then whatever you're wanting to do, and they'll be shown as bullet points in the final document. Here's some more headings. So this is a level 2 heading again with the 2 hashes. Subheadings would be 3 hashes. Subheadings would be 4 hashes. 1 hash would be a really big. So that's like the title of the document would be 1 hash. Okay, and if you've done any HTML before, then these correspond to H1 through H6 tags. So you can have up to 6 hashes if you want. The headings get not much smaller than just plain, basically just becomes plain bold text at that point. And in addition to just kind of writing text, we can also include code chunks. So down here we have our first chunk of code here. And you can see that it's delimited by some special text. So these are 3 backticks, which is on the top left of most keyboards, along with the tilde character. So it's above the tab key on my keyboard and between the tab key and the escape key. Then an open brace, and then R and a close brace. So this just tells the compiler that we'll be using later that this code block contains R code. Okay. The RStudio editor knows how to deal with other types of code as well, so that's why we distinguish. And then we've got a bunch of R code, so we're loading the tidyverse here and having a look at the Quakes data. The head command looks at the first 6 rows by default of the Quakes data. And then we've got the 3 backticks which close it off. And you can see that RStudio automatically recognizes that code plot, puts it on a different background, and also puts some a little toolbar up in the top right. So that toolbar allows us to change properties allows us to essentially execute the code. So the main one we use is the run current chunk button. There's a little green play button there. And if I click that, then it runs that code, and any output from that code is then displayed underneath the code block. So it's in line with the document that we're writing, which is quite nice. So you can see here we've loaded the tidyverse, we've had a look at the Quakes data, and we've got the top 6 rows of the Quakes data is displayed there. So we've got some more writing here, and then we've got another code block down here, which is producing a plot. So the first line here is taking the Quakes data and mutating it, changing it in some way. And the way we're changing it is we're creating a new column called How Deep, and that's equal to if the depth is less than 300, it will set how deep equal to shallow. And if the depth is not less than 300, so the else, it will set it to deep, right? So anything bigger than 300 we're calling deep, and anything smaller than 300 we're calling shallow, and we're going to have a new variable, how deep. Okay, and then we're going to be plotting that, doing a box plot with the x set to how deep and the y set to the magnitude. So we're going to have a look for the difference in the magnitude of earthquakes that are shallow versus earthquakes that are deep. Okay, now just as you can with normal R code, you can run line by line. So if I just put the code on that line, I can use the run button as per usual, and that'll just run the selected line. Okay, Control Enter is the short form. So you can see that when I do that, I create this new dataset Quakes cat. And if I have a look, I've got the new column here. And you can see that there's a relationship between depth and the how deep column, right? So these first two entries are clearly bigger than 300, so they're deep. The next entry is smaller than 300, so it's shallow, and so on, right? So deep when it's bigger than 300, shallow when it's less than 300. Okay, and now we have that, we're going to do a plot. And this shows you, so we're doing a box plot where x is the how deep, right? Either deep or shallow. And the y is the magnitude. And so you can see that there's a difference in these earthquakes between the deep earthquakes and the shallow earthquakes. The shallow earthquakes tend to be larger in magnitude. Okay, probably because they're shallow, you feel them more maybe. I'm not quite sure. Is magnitude a measure independent of depth? I don't know. It's something maybe I'll Google later. So on average, the shallow ones are larger magnitude than the deep ones, but otherwise the distributions are about the same, right? They're skewed to the higher values, so the large majority of the earthquakes are lower, and then there's some extreme values kind of at the high magnitudes. Okay, so that's how you do things in line. Obviously, you can change this as you normally can by adding colours and so on and so forth. Once we've finished doing our changes, which is where we're up to now, then we can actually compile this into a single report. And that's one of the advantages of our Markdown, is that you have your writing, if you like, your text, your narrative that you're telling, is the story that you're telling. You can write as per usual in plain text. You can embellish it as per usual by adding headings and subheadings and tables and lists and bullet points and all the usual stuff that you would do. But in line in the document, you have both your code and the output from the code. So the knit button up the top here is the process of running through and converting the formatting in the Markdown code to kind of output, and also it runs all of the R code in turn and puts the output from it in line. So we'll click that button and see what happens. So you get a bunch of output down the bottom here, and then we get an HTML file which details our work today. So here's our introduction. So you can see that's a level 2 heading. There's the level 1 heading, the title. And you can see here's the piece that we had bolded, and here's the piece that was in italics. And there's our bullet points. Here's our headings, subheadings, sub-subheadings, and so on. And notice that the H1 tag and the H6 tag that I put in are rendered in a different font, and they have a kind of a different background. That's because I put backticks around them. So down in here I used a single backtick to open and close, and that just basically denotes kind of like a code word, if you like. So anything inside, anytime you're kind of writing or you want to indicate that something might be code, you put it in backticks and it just renders it that different color. Now, where is that document gone? There. Okay, and here's our first block of R code. So you can see that it's rendered the R code. There's the library tidyverse command that we had first, and there's the output from it below there. So we've got a bunch of messages, just like you would normally when you run library tidyverse. You get a bunch of messages in the console telling you about all of the packages you're attaching and so forth. And then we have the extra 2 lines, the data quakes and the head quakes, and there's the output from the quakes data set, the first 6 rows. Then further down we have our second code block. So again we have our our lines of code here, and there's the plot in line. So essentially, this is a way of, it's kind of like a lab book that you would perhaps have in the experimental sciences, where you write down everything you do during your particular experiment that you're working on. This is the same thing. We write down everything we do with our analyses in terms of plain text, our code that we use, and then we kind of combine it all together, and it pastes everything together so that we have a set of reproducible work. Okay. Now there's a couple of simple rules that you've got to remember. The first one is that when it creates this document, when it finally knits the document like we're doing here, then it does so with a blank slate. So what it does is it creates a new kind of copy of R that has no data loaded, no packages loaded or anything. You're starting from scratch, and then it runs through your R code blocks in turn from the first one in the file through to the last in sequence, and it runs them line by line. And that's just to ensure that you're not depending on anything that isn't in the Markdown file itself, right? So that you haven't, you've loaded a couple of packages, down in the console here, for example, while you've been working, and it's just making sure that you've also put the loading of those packages into your Markdown file so that it's reproducible. So if things don't work when you get an error when you knit them, it's usually due to an ordering issue. You're using something at a point in the document that you haven't defined yet, or you haven't loaded the library in yet, or something like that. Okay, so that's the first thing to look for. So what you can do in that case is you can, to kind of help troubleshoot it. So let me create an example. So here we're creating our Quake stat, right? Let's use that in the previous data set, right? So we're going to use it here. We'll just have a look at it maybe with the head. Let's use that there and see what happens. Okay, so when I run this code block, it'll work because at this point Quake's cat is loaded, right? Because I've already run this code block down here. So when I run it sort of interactively in the session, then that works, and I get my my Quake's data with the extra categorical variable. But when I knit this, it's going to be starting from a blank slate, so it's not going to know about Quake's cat before it starts, and I only define it further down, so I'm going to get an error. So let's try that and see what happens. And so now I have an error. So error in heads Quake cat, object Quake's cat not found, right? And so the problem is that I've used something before I've defined it in the file, so it's been doing it from a blank slate. And the quickest way to troubleshoot that is to basically clear out everything and rerun things from scratch. So you can, if you click on the broom here in the environment tab, then that will kind of sweep out all of the stuff you've got loaded. Okay, so now my environment is empty, and now when I try and run this first code block, I see the problem immediately. Okay, so I've hit that problem, and now I realize, oh, it's kind of obvious I haven't defined what Quakes is, so I can't be using it there. I've got to define it first, and then maybe I can use it down here, which is what I've done. Okay. The other helpful thing is the button next to the play button. So often when you're troubleshooting things, or if you come back after a long period and you're starting to work further down your document and you've got lots of code blocks above and so on, what you want to do is you want to start by just running all your code blocks from start to finish so that you kind of catch back up to where you were, right? That's what that little button there does. So the one next to the play button, it runs everything except the current one. So every chunk above the current one is run. And so if you run that, it'll go and run all the other ones, and then you can press the play and you're in the right kind of state. Okay, so maybe we'll add a note here about this plot. This plot shows us that So I've just made a comment there on that higher magnitudes compared to the deep quakes. Center box shifted up. the shapes and spreads are somewhat similar, right? So notice when I'm kind of writing about graphs like this, I'm not overly prescriptive. So I kind of look for the general things and not the specifics. So I'm not concerned if the box isn't exactly the same size. In this case, I think they probably are, but if they were a little bit different, that wouldn't concern me. Similarly here, you can see that the range on the shallow plot is actually a little bit bigger than the range on the deep plot. Again, I'm not concerned about that because that's mostly to do with the, just a handful of earthquakes that are much bigger. So instead, I just give general thing. The biggest thing that I notice is the shift in center. Okay, so that's the main thing that I comment on, and then I just say the other things are kind of similar. Okay, so now our turn to do some changes. Go through and have a play with the Markdown syntax to get various things bolded or in italics. Okay, so to bold here, we just put 2 stars around it. Okay, italics, single star. Bold italics would be 3 stars. Okay, there's various other things. So if you have a look under the help menu, there's a cheat sheet. So if you have a look at cheat sheets, then there's a data visualization cheat sheet with ggplot too that tell you about that. And there's another one which is an R Markdown cheat sheet. So we'll click on that, and that's loaded up a browser window, which has downloaded a PDF. And there it is there. Okay, so this will tell us all about our Markdown, and so you can see, how you do various things. So here's the kind of the plain text for it, and this is what it looks like when rendered in HTML. Okay, so there's an unordered list, and there'll be an ordered list somewhere here. Here's an ordered list with 1, 2, and so on. This is how you continue a list afterwards, and so on. So there's lots of information available to kind of help you out. And of course, as per usual, if you have, you want to achieve a particular thing, then just Google how to do it. There's some indication as to how to do tables, for example, down here. Okay. Now, you won't be able to do everything you want to do. So you don't have as much control over the formatting as you would, for example, with a Word document or something like that you're laying out a PDF or something like that. Okay. And that's kind of by design, because we want the thing to be reproducible by others. So we want to be able to give someone else the Markdown file, and they can then reproduce our report. And so because we want that flexibility, we're going to have to give up a little bit in the way, the way it looks. But there are a number of kind of tweaks that you can make to it in order to still get things looking, fairly much how you want things. You can knit to various formats. So here I've got knit to HTML, which is the default, and that's what I suggest you use by default, simply because it's fast. Okay, creating the HTML file is fast, and you can easily kind of jump through it and find out, what you've done. But you can go, for example, to Microsoft Word. So if we knit to Microsoft Word, then it will create a Microsoft Word document. And presumably it will open it, but I'm not sure if it will work on this computer because I don't actually have Word. Let me see if I can open that document. So you notice that when I knit the file, there's my Markdown file there, and there's the HTML that it's created, and there's the Word document that's created. So if I open that, it'll open up in Word, and there's the Word copy. So this is LibreOffice. It's a open source version of Word, but you get the same, you'll get a similar thing with Word. And you can see that, the corresponding heading type stuff, the bullet points, the bolding, the italics, still all works, as does the inline code and output. All that still works. Now, if you do want to knit to Word, you're welcome to, obviously. But the trick is to remember that the Word document is the output. It's not something you should mess with. You should mess with the input so that next time you knit, you don't lose anything that you might have changed in the Word document, right? So all your notes and things should go in the Markdown file so that you've just got the one thing to maintain, and then the output, whether it be HTML or Word or whatever, is then kind of for other people. It's the final kind of version that you might share with other people that aren't interested in changing things. You've also got PDF. This may or may not work depending on your computer. It requires a whole bunch of extra stuff installed. In particular, it requires a LaTeX installation. So I'll just knit it so you can see what it looks like. So here's the workshop in PDF form. Okay. So that's what it looks like there. All right, let's finish off some things. Okay, try altering the plot. Experiment with using a histogram for this and a density plot. Right. So let's create a new code block here, and we'll do it down here. So we'll go insert R, and that will put a new code block, and then we'll just kind of copy and paste what we did before and change it accordingly. So let's try, first of all, we could alter the color. So we could change the color by the how deep. Right, so we get two different colored plots. Obviously here the legend isn't all that much useful. It isn't all that much use because we can kind of see which one's deep and shallow anyway. So you could turn that off if you want with guides color equals none, I think it is. Let's see if that works. Yes. Okay, so that'll turn the color guide off. Okay, I should really spell it out, shouldn't I? There we go. Okay, so that's that one there. But I might instead try a histogram or a density. So let's try that. So instead of a box plot, I'm going to use a histogram. Let's try that straight out of the box and see what we get. So that doesn't work very well when I immediately try it. Okay, and so the problem is that can only have an X or a Y aesthetic and not both. Right, so that makes sense to me. So the problem is that I'm comparing, so when you do a histogram, of course, you supply just the X variable, just the numeric variable, and it computes the Y, right? So I could, for example, drop the how deep, we'll figure out how to get that in there in a moment, and just use X equals magnitude. And then I get my histogram. Let's change the number of bins. Something like that, maybe. Okay, so there's my histogram. Let's get rid of this bottom bit here. Okay, so there's my histogram. But this is just all quakes, right? It's not one or the other. So what you could do is you could change the fill color by how deep. Okay, and you get this here. So what this is doing is it's coloring, is the total height there is based on all of the data, but the coloring is based on a subset. So the blue curve here is the distribution of the shallow earthquakes, and the red, which starts where the blue finishes, so it doesn't start at 0, it starts instead at the blue where the blue finishes, is the distribution of the deep ones. So what is hard to do here is it's hard to compare the two distributions because the red one is not starting at the baseline, right? So that's a bit of a problem. There's a couple of ways around that. One way around it is to change the position. So if we do position equals dodge, so what this does is it essentially allows each of the different fills to be offset from each other, so that now the blue curve has got gaps in it. The gaps are just so that you can fit the red curve in. So the blue curve is the shallow ones, and the red curve is the deep ones. So again, this kind of indicates that the blue is shifted to the right compared to the red, and the shapes are kind of about the same. But again, it's hard to really compare them because we don't really have a proper histogram before, right? Because it's been broken up, so it's kind of hard to compare. The other way to do it is position equals identity. So position equals identity just puts them purely on top of each other, right? So the deep one is drawn first, and then the shallow one is drawn over the top. So they're both at baseline. The problem here, of course, is we can't see through, so we'd have to add some transparency. So we could add, say, alpha equals 0.4, say. Okay, and so now we've maybe not quite that much. 0.5, and so we can see through the blue graph to where the red graph is, and now you can see that the blue is in fact shifted to the right, and that otherwise the shapes are kind of similar. Okay, so that's the histogram. There's various other ways that we could do the same thing, and we'll look at that again when we look at how to do multiple plots on different axes, but on the same, presented on top of each other or something like that. So stacked plot where you have a histogram up here and another one underneath it on separate sets of axes. So we'll see that later. So that's a histogram for comparing groups. We could use a density as well. It takes basically the same format as the histogram. But because it generally doesn't fill things up, you can just have two different colors for the shallow and the deep, or you can use fill if you want, with some transparency. Okay, so that's again comparing the distributions. I like this a lot better than I like this one. I think it just it looks better. It's not subject to those weird things where you're worried particularly about where the data are, that they're all rounded and things like that. You don't have those weird glitches. This big spike here is just due to the fact that there's very slightly more in that category, and you don't really see that as much on the density. So I like that as a kind of better option. So that's how you do density by group. You can put them on top of each other. Or side by side box plots. And the same applies if you've got more than two groups, right? So if we divided it up into like 5 different categories of depth, then you can imagine how the histogram and the density would start looking a bit messy, because you're going to have 5 groups kind of stacked on top of each other, and it's going to be hard to distinguish, even with transparency, which one's which. I mean, you could do it without the fill, maybe with the density, but still then you're going to get kind of 5 separate curves, and it's going to be maybe a little bit hard to compare them when they're stacked to each other. The histogram's going to be even more of a mess, but the box plot is still going to be quite clean, right? You just have 5 box plots next to each other, which will be fine. Okay, so the other thing that we want to talk about is the code block at the top, right? So this block up the top. So you can see it's a bit bigger than it was when I started, because I played around with the output format. So at the moment it's set to PDF because it's listed first. But if I hit the knit button, it will knit to a PDF. Right, and there it is. And you'll see that if I go back to that, you'll see that here's my extra plots been added to it. And if now I knit to HTML, then you can see that it's changed the order here. So HTML is now the first output format. Okay, and there's my HTML with the additional plots and so on in it. So you can see here that title is specified. There's a bunch of other things. So author is another field that you can add. Date would be another one. And the field for it is in quotes, and then the key, if you like, is date colon. Okay. So now you can see when I render that, I'll have that information listed in my document. And there's various other things. So there's a bunch of settings that you can add for, how things are done, how the processing works and all that sort of stuff. That basically just mean that you end up with more stuff written up here. As an example, perhaps I'll load some of the lecture slides that we use. So all the lecture slides are done in our Markdown. And so perhaps let's look at lecture 3, which is the next one coming this week. And I've got all this stuff in my code block. So there's lecture 3, data types and summaries. And this particular lecture uses, and all of them in fact that I do, uses a slightly different output method, which is called Zarangan. And it's basically a version of Markdown that's been developed in order to use the Reveal.js JavaScript library for slides. And so you can see as I go through, I've got similar type of stuff. So I've got a setup chunk here, with a bunch of R code, loading some data in, setting some extra options for the way things work and stuff. And then I've got a heading, right, learning outcomes, and then some bullet points under that, and so on. Okay, there's the next slide. Data today, we'll use the E. coli in italics. And then I've got the code, and then the HTTP link, and so on. Okay, there's various other things in here, like these little bits here, this class middle inverse bit. That's just because I'm doing slides with a particular package that you know, this is going to mean that the things turn out in the middle in a inverted color, so it'll be white on black instead of black on white. Okay. And then I've got data types, I've got some quotes, and then further down I'm going to have some bold text. I've got some magic mathematics here. If I hover over that, you can see the mathematics be rendered. So this is the formula for the mean. Okay, and so on. Right here I'm creating a set of data, and as per usual I can run everything above. Oh, it's not going to work because I'm not in the right folder, I think. Maybe. Yes, I'm not in the right folder, so it's not going to work. You can't load that data in. That's the problem it's having. But if I was in the right folder, then it would be, you know, I could knit that file. Let me switch over to that so you can see how it goes. So I'm just going to set the working directory there. Maybe I'll just knit it so you can see. When it knits, it should set things up. I've got a problem. If I type something here, yes, there we go. I made a change to the. Accidentally put a bit of extra text in. So if I knit that document, then you can see here's the slide for lecture 3. Right, so there's some R output of the HRC set, data set, and so on. There's probably going to be some plots somewhere. Yeah, there we go. Right, and so that's an example of Markdown being used for lecture slides. Okay. That's about it, really. For the rest of it, just kind of play around. You can add some of your code blocks from various other files, and when you're done, you just knit the document. Now, whenever you knit, it saves it, so it saves the Markdown file first. And of course, the only thing you need to save is the Markdown file. You don't need anything else. Okay, so that's the only thing you need to save, because the HTML is just generated from the Markdown file. Okay, which is a nice thing about the reproducibility of our Markdown scripts. That's it.